In today's lesson, we're going to practice factoring expressions. We've talked about greatest common factor, we've talked about expressions and kind of showing them. So now we're going to factor the expressions to write them in a simpler form. Let's take a look. I'm going to warn you this is going to be a fairly long video, so just be prepared for that. Use the model to answer the following questions. Okay, well, let's take a look at the model. All right, I can see here we have a 5 and a 5, and it's 2 times 5, right? And a 3 and a 3, which is 2 times 3. Okay, first question, how many 5s are in the model? Well, I see 2. Okay. How many 3s are in the model? I see, again, 2. And what does the expression represent in words? Okay, I'm going to go ahead and write my answer here. There are 2 of those and 2 of those. Now the expression in words, this is the sum because we know we're putting them together, and you can tell because right here they are together. So this is going to be the sum. So this is the sum of 2 groups of 5 and 2 groups of 3. And I know that's the case because it's the sum of what's on this side and what's on this side. So it's the sum of 2 groups of 5 and 2 groups of 3. And we know it's the sum because, again, they're smushed together. We add them together. That's what sum is. All right. What expression could we write to represent the model? Okay. So it's the sum of, so now we got to figure out this part and put them together. Okay, it's the arrangement of the wording. So 2 groups of 5, so there's 2 times 5, 2 groups of 5 plus 2 groups of 3. 2 groups of 5 plus 2 groups of 3. 2 times 5 plus 2 times 3. Okay, let's continue with this idea, and let's use a different looking model. So this one's a little bit different. To compare them for a moment, a little bit different. Same numbers, different model. All right, first question. How many 5s are in the model? Oh, I see 2. 1 and 2. How many 3s are in the model? Well, I see 2. What does the expression represent in words? Okay, we're adding the sum, so it's going to be the sum, right? Here we have the sum of 5 and 3, right? There are 2 of those groups. So this is going to be 2 groups of this sum. So 2 groups, I'm going to start with 2 groups. 2 groups of the sum, and I know because I'm adding them right here, 2 groups of the sum of 5 and 3. We gotta put them all in words, including the numbers. I almost made my 5 a number 5. 2 groups of the sum of 5 and 3. So we have the sum of 5 and 3, and we have 2 groups of them. 2 groups of the sum of 5 and 3. All right, what expression could we write to represent this model? Well, there's 2 groups of the sum. So we have the sum of 5 plus 3. I want to do that first, the sum plus the sum of 5 plus 3. And we know that we're adding those 2 sums together because, again, they're squished together. Another way that we might be able to write it is 2 groups, 2 of the 5 times 3, or 5 plus 3, I'm sorry. 5 plus, that's a plus sign. Make sure it looks like a plus sign. 5 plus 3. 2 of the 5 plus 3. So here's a 5 plus 3, and we need 2 of them. So this is 2 times 5 plus 3. So either one will be correct. This one's more algebraic. It's more kind of proper what we're looking for. All right, here's my question. looking at these two models, are they equivalent? Are these two models equivalent? Let's look at our expressions. I'm going to move it up here so we can see these two expressions. Are these expressions equivalent? Well, I can see in my models that there are 2 5s and there are 2 3s. I believe they're equivalent. I believe they are. If we take a look at these, I know that they're equivalent because the same thing is happening on either side of the equation. I know that if this equals this, I have 2 5s and I have 2 3s. And I'm adding them all together. This is an example of the distributive property. We talked about this earlier in a couple other lessons. I know you talked about it a little bit last year. This is the distributive property. I'm going to write that. I'm going to pick a different color here. The distributive property. Oops, I got to spell correctly. Distributive property. It's all in how you distribute the factor. Distribute that factor. That might be a word that you want to highlight or make note of in your ISN. Maybe you can put a page number beside it, referring back to when we defined it earlier in our notebook. All right, let's take a look at another example. This one, we're going to move into letters instead of numbers. We had 5s and 3s before. This is going to be similar, but this is letters instead. So we're using some variables. What does the model represent in words? Well, let's take a look. And just like we did on the last one, we're going to put it into words. Okay, so we can do A plus B plus B. Oh my, there's several different ways. So let's, I'm going to do 3 different ways. How about that? I think there might be 3 different ways. So we can do A plus A plus B plus B. A plus A plus B plus B. Okay, that's one way we can put it in words. Another way we might put this into words is I see 2 A's plus, I know it's plus because they're smushed together, 2 A's plus 2 B's. So 2 A's plus 2 B's. A little S up there for my plural, more than one. I'll do my other one over here. I'm going to run out of room here. Maybe I can do 2 times A, because there's A 2 times. So 2 times A plus 2 times B. 2 A's plus 2 B's, 2 times A plus 2 times B. All of those will work. All those are word forms. All right, what does 2A mean? Well, 2A means there are 2 A's. 2B means there are 2 B's. Okay, so the question then asks how many A's are in the model, how many B's are in the model, so we can answer both of those. I believe the next question, I'm going to take a sneak peek here. Okay, let's write this in an expression. All right, I'm going to go ahead and put that over here. I don't have that printed out here, but I'm going to write an expression. So I'm just going to title it expression. So if you were going on in your notes, this might be one that didn't fit on my little page here as I went down. The expression, I'm going to do this one. There is 2A, so 2 times A, plus 2 times B, or 2 A's plus 2 B's. So the simplest expression could be 2 A's plus 2 B's. Okay. Let's go on to the next problem. I'm going to keep this one handy here. Set it up there so that we can use it for later. Okay, what expression can we write to represent the model? So let's look at this model. It looks similar. Put this other one back so we can see. I have it handy. Looks similar, using the same letters, but it's a different representation of the letters and the numbers. Okay. How many A's are in the expression? 2. How many b's are in the expression? 2. What expression can we write to represent this model? All right, so there's an a plus b and an a plus b. Just like on our 5 and 3, this repeats 2 times. A plus b, a plus b. So we have 2 of the a plus b sections. 2 of the a plus b's. That looks different than this one because this doesn't have an a plus b. It has an a and an a, so there's 2 a's first. It's all about how you order it to see how it comes about. Okay, the question is, are the 2 expressions equivalent? Is this expression equivalent to this expression? So I'm going to write it up here. 2a plus 2b, we want to know, does it equal 2 of the a plus b's? Using the distributive property, we can tell that yes, it is equivalent because they have 2 a's here. I'm going to have 2 a's here if I factor it out. I have 2 b's here and 2 b's here. So yes, they are equivalent. So we don't need our question anymore. We know that yes, they are. Okay, let's go see if we can put this to work for ourselves. Okay, we talked about greatest common factor a few lessons back. So we're going to use that greatest common factor, 1, so that we can refresh our memory, and 2, because it's going to help us to use the distributive property, and we're going to write some equivalent expressions. All right, let's see. Let's move on to number 1. All right, the first thing that we want to do is we're going to go back a few lessons when we expanded them. So let's expand 3f plus 3g. Remember, we take the coefficient of the term and the variable, and we're going to split them up. So this really says 3 times f plus 3 times g. Now I'm going to look at these numbers, and I want to find the greatest common factor. Now we know when the numbers are the same, they are their own greatest factor. So the greatest common factor of 3 and 3 is 3. So if we take out the 3's, we take out this 3, I don't know if my finger can fit, so I'll use my pen here. We take out this 3, we're left with f plus g. Now the reason that we cannot keep the multiplication sign is because this coefficient goes with this variable. We can't leave that multiplication sign if we don't have this number. Okay, so we're going to take out this 3 on the multiply. We're going to take out this 3 on the multiply. And we're left with f plus g. So we're going to use the distributive property here. And we're going to take out the greatest common factor of 3 from this expression. If I divide 3 divided by 3, I'm going to be left with f. Oops, I'm sorry. Open parentheses there. And then I'm going to be adding the g. Now, the distributive property, remember, tells me that I can distribute that 3 and I can multiply. So if I multiply 3 times f, I'm going to get a 3f. I'm showing you the proof that it works. Adding, distribute the 3 to the g, and I get 3g. I'm back to my original problem. So first I have to find my 2 numbers. After I expand it, I'm going to find my 2 numbers, find the greatest common factor. That greatest common factor is going to go on the outside of the parentheses. Inside the parentheses is going to be what's left over when I divide that coefficient by the greatest common factor. Let's try one that's not so simple with just its own self. All right, let's start by expanding. Okay, so we have 6 times x plus 9 times y. Looking just at my coefficients of 6 and 9, I need to find the greatest common factor. If I don't know it, I'm going to use one of my methods. So I'm going to use the latter method that we discussed. I see there's a 3 in each number. So 6 divided by 3 is 2. 9 divided by 3 is 3. When I look at my 2 and 3, remember, I'm looking at those last 2 numbers. I don't see anything in common, so my greatest common factor is 3. So I'm going to put 3 on the outside of the parentheses. Now is where it gets a little bit tricky. I need to take 6 and divide it by 3. 6 divided by 3 is 2. 2x. 2 is still the coefficient that goes with the x. Now I'm going to take the next coefficient. Well, I'm going to add. I'm going to add because that's what my original problem tells me to do. I'm going to take my next coefficient of 9 and divide by 3. 9 divided by 3 is 3. I'm going to keep my y, my variable, and my new expression, its equivalent, is 3 times the quantity 2x plus 3y. Let's see if we work it back out, if it works. 3 times 2 is 6x plus 3 times 3 is 9y. Very cool, very cool. Let's try another one, and then I'm going to kind of clue you into something here. Okay. Oh, this is a very tricky one. Let's take a look. I'm going to break this down and expand it out a little bit. 3 times c plus 11 times c. All right, I'm looking at the numbers, and I want to know, are there any common factors? Well, without doing my table, my ladder here, I know that the only factors of 3 are 1 and 3. 3 would be the only number I could use, and 11 is a prime number, so that doesn't work. Now comes the tricky part. I notice that both terms have the letter C in them. So my common factor in this problem is not a number, it's a variable. So my greatest common factor between these two terms is C. That's tricky. If I take the C away from the first factor, or the first term, I'm left with a 3. If I take the C away from the second term, I'm left with 11. Now, I would not take this down any further because I could add, and it could be 14 times C, 14C, but I don't want to because I want to see that this is in the same form as the others that we've talked about. Okay, if I was to take it back through, and you're not going to have to do this, but this is just proof that it works. I have 3C, and yes, I always put the number, the coefficient first, plus 11C, and it works. Okay, let's try one more, and then I'm going to clue you in. I promise I will clue you in on this very cool trick that we can use to do this. Okay, so I'm going to go ahead and expand it. 24 times b plus 8. And 8's not multiplied by anything, so it's just going to be an 8. Okay, looking at my numbers, 8 and 24, I need to find a common factor, the greatest common factor, and so I'm not really sure what it is, so I'm going to go ahead and put it up here. For the trick that I'm going to show you, it has to do with the ladder over here. Some of you may have already recognized it, don't tell. I always have to put the first coefficient first and the second number or coefficient second. It has to be in the order that they give them to you for the trick to work. Okay, I notice I can pull out a 2. 24 divided by 2 is 12. 8 divided by 2 is 4. Oh, I know that 4 is a factor of 12, so I can pull out a 4. 12 divided by 4 is 3. 4 divided by 4 is 1. Well, I've got a 1, so I must be done. I'm going to multiply the numbers to the left. 2 times 4 is 8. So my greatest common factor is 8. And you may have been able to look at that and see it without this table. That is perfectly fine. If you can do that, great. I'm showing those just in case we can't or we want to double check. 8 goes on the outside as our greatest common factor. 24 divided by 8 is 3. Ooh, I'm letting you in on my secret. It has a variable that goes with it. 3 is the coefficient. Plus 8 divided by 8 is 1. Oh, looky there. Okay, let's double check it. We've double checked all the others. 8 times 3 is 24 with the variable b, plus 8 times 1 is 8. Now, here's my trick, and it will work for almost every one of them. If you put the variable in here, let's pretend that we put the variable in here. This was x, and this was y. So if we keep that variable the whole time and we bring it down, 3y, 2x, when we are done, this very bottom one, with the greatest common factor, and sometimes it's two numbers, but this part right here is this part right here. Look at that! That's amazing. Let's look at this one. I'm going to keep my variable, and this one, remember, didn't have a variable, so I'm going to keep the b the whole way down, just so it's there, and I might do that as I'm going, but I didn't want to tell you my trick yet. So I'm going to look at this bottom part right here. And I'm going to leave out that 4 this time because it's not 4. It's not 4, it's 8 because I use all of this. And then the 3b plus 1 is right there. So if you use the ladder method to find your greatest common factor, it should give you your distributive property equivalent expression down here. Isn't that great? Oh, I love tricks. All right, well, that concludes our very long lesson for today. Thank you for sticking with me. Remember, if you have questions, you know the drill. Please put them in your ISN, and I'll see you tomorrow.